Happy Wednesday. So we missed Monday. This is a 1 day week, which is kind of nice, I guess. Wednesday we did what? Domain and range, right? Today we're going to look at what we should have done Monday. We're going to look at the properties of graphs or average rate of change, the idea of symmetry, idea of increasing and decreasing, and the idea of concavity. Right, so concave versus convex. Right.
There's a lot of people dropped, huh?
Yeah, about half after the first quiz, which is odd because quizzes don't really count for that much. Yeah, about half dropped.
Sheets like,
Crazy,
did you sign in? Yeah, that's it?
It was like 2 pages.
About half dropped. Was 21, now there's 11.
If it was set for only 11 people at the beginning,
It would have run.
It would have what?
It would have run. Class would have run.
Oh, class would have run still? Oh, okay.
I think you need 7.
7?
For the
Yeah,
class
'cause I had one of the other classes that had dropped because there wasn't enough.
Yeah, I think it's 7 you need. But at this point, the course is now set, so the rest of you can drop and I still get paid. Smaller classes, in my opinion, are better anyway.
Cool.
Yeah.
So we know who can cut it and who can't. Average rate of change. All right, so the idea of average rate of change, and I believe went over this in the video. It's also slope of a secant line. Right. So this is going to be an important concept. The slope of secant line and the idea of secant lines is an important concept for calc. And let's just say we have some function f of x. Yeah, that's good. Technology is a wonderful thing.
That's crazy.
Wow.
That line is a secant line. Secant line.
Weekend.
SE, yeah.
Secant. Right, so a secant line is just any line of a function that passes through 2 points. Then we also have what the idea of a tangent line. You'll study that in calculus. Well, slope of a line is what? Well, that's slope-intercept form of a line. So m is the slope. What is slope?
Delta Y over delta X.
Right? Rise over run. Right? Change in the y values over change in the x values. We call it m sub sec to represent the slope for the secant line. Right? So in this case, right, it'd be f of b minus f of a over b minus a. Right. To see how that's related to average rate of change. Let's say you go on a 300-mile road trip. And it takes you 6 hours. What was your average speed? 300-mile road trip takes you 6 hours. What was your average speed?
50 miles an hour,
How'd you get it?
30 by 6. I mean, 300 by 6.
So you did your,
Did I say 30 miles an hour? I did.
you did 50 and then you said 30 miles, but I
Yeah,
know what you
okay,
meant.
so, yeah.
Right. So you did what? You did the distance, right?
Yeah.
Divided by the time it took you. So your
you get-
change in distance divided by your change in time. Just precisely that. If you let now your horizontal axis be time and your vertical axis be distance, that's exactly slope of a secant line between the points, in this case, 0 and 6 hours. That's sub SEC. So average rate of change is represented as a change in general is represented as a capital delta. So this represents average rate of change. F sub average, F sub AVG. SEC, it's a sub. Average rate of change, 7x plus 12 on the interval 2, 8. It's just change in the F value divided by change in the X value. F of 8, 7 times 8, 56. Plus 12, 68. I actually did something different in my notes to make it easier. Not actually going to evaluate it. F of 2, 7 times 2, 14. And then, of course, plus 12. Divided by 8 minus 2 is 6. And then look at that, 12 minus 12. Constants drop out. 56 minus 14. 46, 42. Average rate of change is 7.
Where'd you get that? Where'd you get the 14 and the 12?
So how do you evaluate F of 8? You're talking about this one here then? 14 plus 12?
Yeah.
How do you evaluate F of 2? Let me just plug 2 in for X.
Oh.
7 times 2? and then just plus 12. But so instead of actually evaluating it here, I did it this way to show that, oh, look, the constants will just drop out. So really it's just 56 minus 14 instead of whatever it is, 68 minus 26.
Gotcha.
Nice. Let's say we were in a horrific rush on a test. Would it be okay on this to say it's gonna be 7 because it's linear?
In this case, yes, only because it is a linear function.
Because you know the slope is gonna be 7 of that line, because it's basically an NX plus B,
Yes,
but that's just for straight.
because
line.
it's only because it's linear.
Yeah.
Right, because the secant line is just the segment, the line segment. It's actually
And
the
that
same
gives
line, right?
through all of
The
it,
secant line is 7x plus 12 in this case.
only for linear stuff.
Yes. Which means, by the way, 2 is the same thing, isn't it? It's also linear. But we're just going to do the standard formula.
Look, I have a different grade.
Yeah, but I mean, the idea is the same. It's just the slope of that line. Right? By the way, the units for rate of change. Units of the vertical axis per units of the horizontal axis, right? So going back to speed, your vertical axis had units of miles, horizontal axis had units of hour. So the units of change would be miles per hour.
Can you just explain what's next to the diagonal one more time?
It's just f, right, the function, and then average, sub AVG. Just to signify that this is representing an average and not an instantaneous, which you study in calculus. F of 0 is easy. It's 3/9, right? Minus f of -5. So it would be 3 minus 25 all over 9, right? Or plus 25,
Yeah.
right? But we can write that as 2 separate fractions, can't we? Isn't that the same as 3/9 plus 25/9? And that's all over 5. Again, the reason to do that, look at that, 3/9 minus 3/9. Numerator is left with -25 over 9. Then all that's over 5. That's the same thing as what? -25/9 times 1/5, isn't it? No guess,
Divided by 5, multiplied by reciprocal.
right? Which is -5/9. 25 over 5 is 5. So it's average rate of change. Formula is the same, just your function and your interval that will change. I don't think I have one for average rate of change. Might be 1 or 2 in the video. Oops. So the idea of symmetry. Graph of relation, right? So not talking about just functions. Right. Parabola is a function. A circle is not, but they both have graphs. They're both relations. So graph of relation is said to be symmetric with respect to the y-axis if both x and negative x result in the same y value. Symmetric with respect to the x if both y and negative y result in the same x. Symmetric with respect to the origin if replacing x with negative x and y with negative y give you the same relation. There's other type of symmetries as well. We're not going to deal with those. You could have symmetry along any line. What we're going to do for the next several problems is determine whether the graph is symmetric with respect to the x-axis, the y-axis, the origin, or none. You don't have to have symmetry. Now, let's check the y-axis first. What we want to do, replace x with negative x. If you get the same relation, you have symmetry. So I want y equals 4 times negative x. That's negative 4x. That's not the same. Right? Y equals 4x versus y equals negative 4x, they're not the same. So no symmetry with respect to the y. Check the x-axis, replace y with negative y, see if you get the same relation. Doing so, we get negative y equals 4x, right? Well, that's not the same. So we do not have symmetry about the x-axis. The origin. Replace y with negative y, replace x with negative x. You'll wind up with negative y equals negative 4x. Is that the same relation?
Yeah.
It is. You can just multiply both sides by -1. We have symmetry about the origin.
Can you spell so I can get a picture of that paragraph? Thank you.
Oh, that's not what I wanted. The graph, let's just take a look. So f of x is y, so that equals 4x, right? That is definitely symmetric about the origin. X squared plus y squared is equal to 8. Right. Should recognize this as a circle centered at the origin, radius square root of 8. This is a circle centered about the origin with a radius of square root 8. It circles x squared plus y squared equals r squared if it's centered at the origin.
This is a circle centered at the origin 8.
With radius root 8. Because the square of the radius is 8 in this case. Replace x with negative x. What's negative x squared? It's the same, isn't it? We have symmetry about the y. Replace y with negative y. Same argument. Negative y squared is y squared. We have symmetry about the x-axis. Replace both x and y with their negatives. Gives you the same. So it's symmetric also about the origin. We have all three types of symmetry. right? X, Y, and origin. Now, let's hit tab to bring that back up. Scroll up. Escape. Right. Do not know if the TI-84 can do this. TI-84 might be locked into graphing functions only, right? Not relations. And specifically functions of the form y equals f of x. But the TI Inspire can also graph relations. That's history menu. I think what I have to do. Yeah, if I left click, oh, it can also graph differential equations. That's really nice. But that's left. I don't think you can left click on here. All right, so this middle button here acts as a mouse. All right, so if you just scroll your finger along it, it'll bring up a mouse. Then obviously just clicking it acts as a left click. I do not know how to do a right click. So what you're going to have to do is with the equals, just hit delete one more time. And then you can see not only can you graph relations, but also inequalities. Actually, it's in here. Yeah, there it is. You can also just do menu, graph entry, which is number 3, and then you get the same things, right? We want a relation, so it would be number 2. Boom, we're there. Now we just type in the actual relation itself. Squared plus y squared equals, right? So there's your equal. 8, enter. Why is that still there? Problem solved. Well, look, right? It's definitely symmetric about the y-axis. Definitely symmetric about the x, and symmetric about the origin.
Well, if it's symmetric to x axis and y axis, do you even need to check the origin?
If it's symmetric about both,
About
then,
both
then it
x
should
and
be
y.
automatically symmetric about the origin.
Yeah, I'm trying to visualize a way it couldn't be.
I don't think it can be.
Yeah.
Not in the real plane, anyway.
Oh.
Maybe in the complex, but I'm not too sure.
We're not going there.
No. It's been half an hour already. Time flies when you're having fun. But better have been an agreement, not a yeah, okay, this is not fun. If you're not having fun, automatic F. X times y squared is equal to 1. Again, this is a relation. Y-axis, we replace x with negative x. That gives us the relation negative xy squared is equal to 1. Clearly not the same. Do not have symmetry about the y. Replace y with negative y. Quantity of negative y squared is just y squared again, isn't it? That is the same. So we have symmetry about the x. The clever of us should not have to check this.
It's not both, then it's automatically no way to be symmetrical.
Not entirely true. That one wasn't symmetric about both the x and y, but it was still symmetric about the origin. Because we have one of the axis symmetries, but not both, it can't be about the origin. If it's symmetric about both axes, it's automatically about the origin. If it's symmetric about one but not the other, it can't be symmetric about the origin. It could be, yes. Doesn't mean it automatically is.
If it's a
It
line,
could be.
if it's a line passing through here.
It would be, yes. That's not the only type. You have others as well.
All right.
Like 1 over x, for instance, would be symmetric about the origin. Right, but we're going to check it anyway because it's fun. Why not? Replace both x and y with their negatives. We get negative xy squared equal to 1. Clearly not the same. Therefore, the graph is symmetric about the x-axis.
We'll have to write our answer like that. Yeah.
Because it's asking you how it's symmetric, yeah. I mean, you could just write down symmetric about the x-axis. That's fine as well.
As long as we just jot down that that's
Right,
what
yes.
I'm trying to say.
Right, so this would be your work. Right here. This is the interpretation of your work. Right, so both are important in mathematics.
So we'll get partial credit if we didn't do one
Right.
or the other.
Right. More so, you get more partial credit if you just show the work. Right, if you just give me symmetric about the x-axis, you'll probably get a point and I'll go, how do you know?
Yeah.
Right, just give me the work. It might be 5 or 6 points depending on my mood at that time. Let's go ahead and delete this relation because we have a new relation. So we want xy squared, right? Is equal to 1. It gives me an error.
Well, it's not in function.
It's in relation form. I have a plotting of relation, right?
Oh.
So why am I getting an error?
Cause it can't be cracked.
It can be. The calculator is reading x, y as a single variable. You cannot do implied multiplication.
Oh,
Otherwise, it's going to read x, y as one single variable instead of x times y. So it's reading this as x, y as one variable squared. So think of it like z squared is equal to 1, right? So what I have to do, either that or just do times.
Like, if you were to have it clear.
You may.
What is this TI Inspire? Is it just on?
So this is the TI Inspire CX. When you get the calculator, you automatically get a license for the student software, which is very similar to what I'm using. I'm obviously using the teacher software.
Yeah.
I'm just using the student component. The teacher software also lets me do like activities that I can send out and tests on here as well, which I never use. So your student software will be almost identical to this if you mess with some settings for the viewing.
So we have to buy the calculator first.
And it'll give you a license. You can also try and find the license just for the software somewhere online. Problem is, it's only a yearly license.
You need this?
Not the software.
The calculator.
Yeah, you'll need, not necessarily this calculator. TI-84 is also fine, TI-83. You'll
Would it
need,
be a physical one?
you need a graphing calculator.
Is it like,
And yes, I would say physical because a lot of the online stuff is a computer algebra system, which you're not allowed to use.
can I get in and show you my calculator to see if it's that?
That's fine.
You said it's TI 84 or 83 that?
The TI-83, the TI-84, I think the TI-83 Plus is fine. I'd have to look at it, but I don't think it does symbolic manipulation. Or the TI Inspire CX or CX2. But be careful because there's two versions of the CX and CX2. There's a CAS version and a non-CAS. You're not allowed to use the CAS. CAS means computer algebra system. It does symbolic manipulation. So you no longer have to actually solve an equation by hand. You can just plug it into the calculator and say solve, and it does it. It can also do derivatives for you and integrals and simplifications, factoring. It can do all that. Very useful in upper level math courses.
Yeah, but
Very useful. Can't tell you how many times I've used it. Right, so you can clearly see, right, this is symmetric about the x-axis. Silly mouse. What about x equals y squared plus 1? Right, so y-axis. Replace x with negative x, see what we get. Negative x equals y squared plus 1. Well, that's not the same now, is it? So we do not have symmetry. x-axis. Replace y with negative y. Well, that is the same. Excuse me. Oh joy, feels like I'm getting a sinus infection. That's lovely.
It's getting cold.
Also, doesn't help that both your kids are sick.
Problem is, if I get even the slightest cold, I'll get a sinus infection as well. I have bad sinuses.
Their immune system.
I actually have a pretty strong immune system. I very rarely get sick. At least I
Oh,
used to
what?
very rarely get sick until I had kids. Then of course you have a kid and he loves to, get sick and then run up into your face and go, "I love you," and then cough in your face. Yeah. Mhm. Go up to his little sister and do the same thing. I'll get him back. I'll get him back. When I get sick, I'll hack all over in his face. How do you like it, bastard? Sharing's caring after all. Right, so we should already know it's not going to be symmetric about the origin, right? So let's just check it. Yep. So we get negative x is y squared plus 1, which is not the same, so it's not symmetric about the origin. That's right. And then the problem is, if I have a sinus infection, I can even get a fever with it. That's how bad my sinus infections get. So it's almost like I have a cold, even though I don't. It's just sinus infection.
We won't have class.
No, if I know it's just a sinus infection, I come in. Again, I'll know if it's just a sinus infection. Right, graph the relation x equals y squared plus 1. I have to stop saying graph. It's technically I'm plotting the relation. So there are two ways you can do this. Obviously, use the relation feature, or if you don't have that feature, you can plot this as y equals x squared plus 1. But then you just have to remember in your mind to flip it 90 degrees. It is a parabola. But it's a parabola along the x-axis instead of the y-axis. And if you did the other method I was talking about, it'd look just like this, except it'd start here and open upwards, right? So you just have to remember, oh wait, so you have to rotate it 90 degrees. So symmetric about the x, clearly. Right? What about y equals x cubed? So what is the quantity of negative x cubed? Negative x what?
So I got. My bad. Oh.
Why is that? Okay, never mind, I understand.
That's not the same, is it? Don't feel bad. My Calc 3 students make these mistakes too. And they're in Calc 3, so they should know better. Sometimes I just look at them and go, how did you make it this far? Replace y with negative y. Negative y equals x cubed, so we don't have symmetry about the x. Check out the origin. Replace y with negative y, replace x with negative x. We get what? Negative y is equal to negative x cubed. Is that the same? Yes. All you have to do is multiply both sides by -1. Oh, I didn't actually look at that. I don't actually write out in number 6 that it was symmetric about the y-axis. And nobody caught me, so you all lose 5 points.
Put it down on my notes, but you didn't write it down in there. So you lose
Like,
5 points.
likely excuse. Yeah, but you didn't tell me, so you lose 5 points. And now for trying to show off, you're going to lose another 5 points. So graph is symmetric about the x-axis there. Here, graph is symmetric about the origin. And simply because I'm lazy, I'm going to leave it in relation form. I also have to actually do y equals x cubed instead. Yeah, still symmetric about the origin. Bless you.
If you put in negative y and negative x, are still do the same thing. It's so. Yeah. Because you just multiply. X.
Because you can just multiply both sides here by -1 and you get y equals x cubed again. What y equals square root of x? Place x with negative x. Is that the same relation? So we do not have symmetry about the y-axis. Replace y with negative y. Do we have the same relation? So we do not have symmetry about the x-axis. Replace y with negative y, replace x with negative x. Do we get the same relation? No.
Well, if it is a symmetrical, then we have to write each and every one.
That doesn't, just because it doesn't have any of those three symmetries does not necessarily mean it has no symmetry. There are other types of symmetry. This one happens to have no symmetry. But I only know that because I know what the graph looks like. Just from this work, you can't determine that. And same thing, because I'm lazy and don't feel like going back to function mode. Right, so you see no symmetry about the origin, no symmetry about the x, and no symmetry about the y. By the way, isn't that half of x equals y squared, though?
Sure, if you square both sides of the equals.
That's another way you can get around graphing things like x equals y squared. You can just graph x equals square root of y and, or I'm sorry, y equals square root of x and y equals negative square root of x on the same axis, and it'll give you x equals y squared. There's a similar trick for doing circles too. Questions on symmetry? You're not gonna let me. Okay, then I can fix that. Just do this. No, I don't want you bold. And then I have to paste. I didn't space paste. Perfect. Got there eventually. So the idea of increasing and decreasing. Fairly straightforward concept. We're only going to deal with determining increasing and decreasing from graphs. So if the graph read from left to right, the y values are getting smaller, then it's decreasing. The y values are getting larger, it's increasing. Very straightforward.
Wait, that's it?
I believe I give a technical definition in the video. Y values are getting smaller, then your function is decreasing. Y values are getting larger, your function is increasing.
Now, would the interval, the first interval be like negative infinity, I'll be parentheses, negative infinity?
Yeah, I'll get there.
Because when it hits the point, it's not decreasing, right? So would it be like a closed or open?
Yeah, we're going to discuss that very shortly.
Okay, all right.
There's also an idea of monotonicity. So if the function is strictly increasing or strictly decreasing, we say it's a monotone function. Right, so it's monotonic increasing or monotonic decreasing.
Monotonicity.
Yes,
Write that down.
it's not really important yet.
The state of being monotonous is monotonous.
Right. So you can look at this graph and go, this graph is clearly not monotone. Right. Now, let's start with increasing. Increasing over, right? So we want intervals where it is increasing. And so we'd all agree it's increasing here, right? Let's see if I can highlight it. Right, that's clearly increasing. Since we just want intervals, we're going to look for the x values. Is that negative 1.5? Two. At the points where it switches, they're constant. So no, those points are not included. Intervals for increasing and decreasing are always open. Where it switches from decreasing to increasing, there's what's known as a local max. Where it's switching from decreasing to increasing, there's a local min. And so there'd be a local max at 2. Right, and the value would be what, 4? Again, you can only tell that from the graph, though.
Explain how you got the increase over 3. Sorry.
Right, so you agree the highlighted is increasing, right? Where does it start? And you just read it from. And then same thing, where is it ending? Ends at 2. In calculus, you'll be able to do this without a graph. I'll just give you I could just give you a function and you can determine where it's increasing and where it's decreasing, which is very handy. That's where it'd be decreasing, right? Because we have to pay attention. There are arrows on this graph. That means it extends forever. So minus infinity to minus 3/2 unioned with 2 to positive infinity. But what is infinity?
Never ends. No matter what, all real numbers.
It doesn't tell me what infinity actually is. What's infinite?
Continuation of real numbers.
It is something we made up. Very weird things happen with infinity. You can also wind up with an infinity less than infinity.
What?
Or if you're in the playground, infinity plus 1.
That actually is a concept, which is just infinity.
So. That important to this lesson?
Just don't try and treat infinity as a number, because it is not. Weird things happen with infinity.
You only use infinity for like the internal notation and all that, right? A lot more.
Yeah. You'll use it in calculus too. A lot in calculus, actually. Why did you do that? That'll work. What about here? Where are we increasing?
-4.
Well, all the way from the negative
Oh,
infinity.
yeah, negative infinity.
What?
Negative 5/2.
Is that it?
One open.
Then where are we decreasing?
Over 2. -1.
And that's it. Where are we increasing?
Negative infinity. To 2 or 1.
May not exactly be 1, but just approximation, I'll accept it. Is that it?
Union with negative infinity.
So we already have negative infinity to 1, so you can't have negative infinity again. And again, difficult to tell if it's exactly at 4, but it's good enough.
Isn't that kind of an assumption about it being exactly 3?
Yeah.
Not really.
I mean, this has got to be some kind of piecewise function, right?
No. There's a vertical asymptote at 3.
Oh.
This could be something like 1 over x minus 3. It's not actually 1 over x minus 3. It wouldn't look like this. No, this one's definitely not 1 over x minus 3. But that'd be a case where you'd have a vertical asymptote at 3. It's not piecewise. There's some kind of squareds involved. Where's it decreasing?
And the union 4 and infinity.
Yep, that's what I'd go with. Where are we increasing? Where are we decreasing? So increasing first.
Increasing from 1 to infinity.
What about decreasing?
Infinity. Infinity to 1.
Yeah, I'd accept that. Headache later.
You get headaches from not putting your glasses on.
Mm-hmm. I sure, that's.
Oh yeah.
I wish I get a headache if I have one of my glasses. Too long.
Yeah, I'm the opposite.
Well, these aren't prescription glasses, they're just to block the blue light.
CVS special.
When
That's what I got.
you look at a computer screen all
I'm
day,
too- I'm too stubborn to get the glasses.
I probably need prescription glasses, but I didn't have optical insurance last year. Have it this year, I just have to find time to make an appointment. That's increasing and decreasing. Questions? think I'm gonna actually skip the concavity problems because they are really difficult without calculus, and also because I couldn't for the life of me get the pictures to come out right. I'll just show you one.
My only question is when it's like, we said it was 3/2 on like number 9. Is because it was on number 3, but it was like in between.
Well, not 3, right? Halfway between -2 and -1, about.
Yeah, about.
So that'd be a -1.5, right?
3.
Which is negative
That's
3
what I
halves.
said.
Yeah, that's why.
And also with the other one, with the 5/2, same.
Same idea, yeah. And so again, I couldn't get the pictures to come out right. So, but the idea of concavity, right? So this would be concave, opens upwards. And this is convex, opens downwards. When trying to find intervals without calculus, it is really guessing. Right? Because the concavity doesn't switch here. We typically say concavity is going to switch halfway between. And so it would switch from up to down halfway between here. So maybe right here at 1. But without calculus, you can't get an exact value of where it switches. Right, so I'd say this would probably be concave up minus infinity to 1, and then concave down or convex from 1 to infinity. Formal definition of concave up versus concave down also requires calculus. Has to do with the derivative. So I can't even give you a formal definition of concavity.
And the derivative is what we're learning in Cal.
It's the second thing you learn in calc. Start with limits and then derivatives.
I know there's one girl that has been going to college forever, and she hasn't passed Cal 1 not once, and I think she's done about 6 times.
I'm surprised they're letting us keep going.
Yeah.
Wow.
So now she's like checking her whole life and seeing if school is even the way to go after she put in